Maybe one question up front. Do we have people from the automotive industry in this room? One, okay. From where? Volkswagen. Volkswagen? Okay, great. Super interesting. This case will play a crucial role in automotive. We want to talk about how can we use our information model to reduce search time in electronic troubleshooting. It's a huge problem. Maybe we can close the door as long as it's so loud. What do we see here? It's the end-of-line area in a car plant. So you can see a car. It comes here out of production. It looks already finished, but it has some software or electric troubles. Technicians now take a device, a testing device, to read what symptoms the car actually has. And what they will receive is a list of all the ECUs, so the control units in the vehicle, which do work and which do not work properly. A DTC is what's called a diagnostic trouble code, so a symptom from the testing device. And now the challenge is to grasp this whole understanding of the architecture Robert just has shown in his Star Wars looking picture with all the components talking to each other. How does the world look today? The technicians have a small PC with a PDF that represents all the wiring in the vehicle. It has more than 1,800 pages, and it's quite hard to get an understanding of the overall architecture. Why is it so long? You have a complete model line represented here, and one customer decided to get the big sound system, the other one decided to get the small one, and both has to be represented in here. The technicians and engineers have to understand what specific vehicle do I have in front of me, what modules are configured in there, and what wires actually are relevant for my case. These are only 5 pages out of the 1,800. We want to zoom in one specific case. It's the control unit for the right seat. So it is connected to various motors, sensors, actuators, and you can just get a feeling of the complexity. What often happens is that the actual root cause is not even in here. Robert just showed us that a connection can go, or signal from 2 software modules can go through various wires. So it does not have to be included in here, but maybe from a component to a different one. So if we open a second component and cannot find it here, there opens just another tree of options. So it's super complex. And this is exactly how one cause or one root cause for an error picture, we call it, could look like. So we have 2 DTCs thrown by 2 control units, but the actual root cause might be here. Maybe a wire is broken, some technician drilled through it, or a pin is broken, or a connector is not plugged in. These are typical use cases in the production sites. So let's look into our solution. What application do we offer for customers? Or first, let's sum it up. So what do we see? It's super time intensive to troubleshoot electric errors. We have outdated tools, so a PDF to Command F through. We have like super complex functions, especially when we look into ADAS, so automated driving functions. They use plenty of control units and sensors. And we also have the huge solution space that we don't have like configuration specific view on the architecture, but always the overall possibilities in the vehicle line. How do we help solving this? This is one application we built for automotive customers. For example, for Mercedes. This model represents one specific vehicle. Up here you can see a VIN. It's a vehicle identification number, and it contains information of which modules are actually built in this vehicle. So we have a vehicle-specific view. Down here on the right side, you see all the symptoms they get from their testing device. So it's live connected to the data from the testing device. What you can see here already is the 3D localization in the vehicle, and it helps them a lot to get a first feeling on where the errors are located. On the upper right-hand side, we suggest probable root causes. And we do this by analyzing the network and seeing where are two problems coming together. Maybe it's a connector, and every device that is connected to this connector has a trouble code. So we suggest, please first look at the connector. What the technicians can do here is they can interactively analyze their architecture. They can click on components, see the faces of the relevant connectors, get metadata out of their systems. It could be different names for components. It happens a lot that engineering is using names for components and production has completely different names, and it's hard to bring them together. For us, it's not a big problem. We just add the information from the engineering department and from the production department and put it next to each other. We also add information about wires, colors, length, and cross-sections. And as you can see, we reduce the solution space to one specific path, similar to the path that Robert has shown, and just give the view that is necessary to really troubleshoot this specific error. The technician also can search in this architecture. This is shown here. So he can select one specific component and see all the selections or all the connections in the vehicle. So this helps them to analyze efficiently how the vehicle should work and how it doesn't. One important thing after analyzing and seeing where the probable root cause might be is really helping them to understand where the wire is routed through the vehicle. So what we do here is taking 3D geometries of wires of our components and placing it in the vehicle to make it really easy. What happens a lot is demounting wrong parts because they think, okay, the wire goes here, but actually it goes somewhere else. So we want to make it as fast as possible to find the root cause, to fix it, and reduce the time from average 4 hours to 30 minutes. What did we achieve here? We made it really easy and fast to fix electric errors and also software-related errors. We are able to analyze our network and take live data to make a probable root cause suggestions for the technicians. We are also able to provide configuration specific, so vehicle configuration specific product data. And most important, we spread knowledge from various departments. We take engineering data provided to the technicians in the production side. What we also do is bringing the data about the most relevant components that always break or were always trouble secure, and bring it back to the engineering department so that they can start fixing it or finding solutions that it does not happen in the future. What's also interesting where we go in the future and right now with some customers is taking the knowledge from the production side and bring it into after sales. So when you take your car to the workshop, it also gets repaired as fast as possible. That was my presentation. If you have questions to it, I'm more than happy to answer them.